You got a lot of z's flying around in your complex numbers, right? Now, I'm not a huge fan of writing it like this. However, when you're in an exam, we know you're rushing, I'd rush as well. Your legibility just kind of dies badly. Your writing sort of went down a bad way, okay? And mine would too, okay? However, therefore, especially when you've got like z squareds around, and let's face it, you've always got z squareds around, okay? You have to do something to tell me that's a z and not a 2, okay? Z's look like 2s on a good day. On a bad day, like when you're doing an exam and you're in a hurry, it's a mess, okay? I only got you the marks because I knew what you were writing, but there's no guarantees that that will happen. So that's why I put my dash through my Z. That's pretty unambiguous, okay? Even if you're in a hurry, anyway, it's clear. Now, what we're required to prove? You need to use De Moivre's theorem to prove this. Now, how are we going to do it? A lot of you are still in that bad habit of when you have something to prove, you go from the left-hand side and you do something to it. And then you go to the right-hand side and you do something to it. And you sort of get them to look close enough and then you say, fine, I'm finished, okay? But that is not what you are required to prove. You are required to prove that one of them is equal to the other. If you can do it from both sides, you can do it from one side to the other. You just need to take those steps and reverse it, right? Just present it properly. Over and over again, as I was marking throughout this paper, the drum that kept on being beat was the mathematical ability is there, the communication and the presentation are not, okay? And you will get killed in the HSC for that. They'll just say 0. It's not presented properly, right? It doesn't matter how much understanding you actually had there if you can't translate it onto the page. Okay? So here's the way I would do it. I'd say, look, here's the left-hand side. You go with the left because they've told you to use De Moivre's, right? So if you don't use it, you get 0, right? If they what's the word I'm looking for? If they stipulate a method, you have to use it. Okay. So you just do your expansion here. Okay. Now, at this point, this is where you use the theorem, right? But wow, we were sloppy. Again, you're gonna get sick of me saying it, okay? But present your answer clearly. If someone giving a speech in English, right? If you were giving a speech in English, and the quotes are great, and the connections are great, and the thesis is perfect, and the whole time and mumbled like that. That's kind of the equivalent of what we were doing mathematically, right? You're presenting very poorly. When you do your powers here, right, and you translate it in, you should write it with your brackets there, right? You don't need so many brackets. The computer can get away with it because it's perfectly legible every time. When you guys are ready to join the rest of us, you cannot, right? I saw some people writing this. Sine minus n theta, like that. What is that? I take it you mean this, right? But wow, and the number of variations I saw on that, like this, I think I saw -1 times. What is this exactly? Okay? Be careful. I mean, you don't really need to write that. It's a bit excessive, okay? But still, it's about trying to make your reasoning clear. So you've got this here, I sine n theta here. That's one. And then you've got your other one with your negative power, okay? Now, do you have to say by De Moivre's theorem? Probably don't have to, but what are we trying to do here, right? Are we trying to write the minimum, or are we trying to communicate as clearly as possible, right? So you should have on your corrections, I didn't deduct it there, right? Did I spell it right? I spelled it wrong. Yeah, I spelled it right. You should say it. You should say it, just like Pythagoras. If we quote Pythagoras, you should quote this, right? Now, from there, again, in exactly the same way, you went to the next line, but you said nothing as to why. Okay, what is the next line? What truth, what property are you going to use about cos and sine, which will let you get to what you're trying to prove? What's the property? You're going to do something with these minus signs, right? You're going to say cos n theta, I sine n theta. What happens to this? It just becomes cos n theta, right? But why? Why? because it's an even function, right? So therefore f of minus x is the same as f of x, right? In the same way, you're going to do a trick with this, minus. But why? Because it's an odd function, right? But I don't know if anyone actually said that. You're just expecting the marker to know that that's what you meant, okay? Now, here's the thing, right? We pay extra attention to what's going on here because you already know what the answer is, right? Someone who doesn't know what they're doing can see at this point, I have to get rid of my signs, right? And this cos, which is negative, it'll have to become positive somehow, right? So you don't need to understand what's going on to write down these lines. You need to provide the reasons to show that you do understand what's going on. Okay? Communicate it, please. I was pretty gracious on you this time because it was the first assessment that I was marking for you, okay? But we need to tighten this up pretty bad. Okay? And that's where you get the result that you're looking for. Okay?